Degree of the differential equation is defined if it is a polynomial equation of its derivative. Involves the derivative of the dependent variable with respect to the independent variable in types of a polynomial equation, and it is called as a differential equation. Then the degree of the differential equation is the highest power of the highest order derivative. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So today in this session, we are going to begin with the new chapter, Differential Equation. So what is this differential equation? So previously you have learned what do you mean by polynomial equations. A polynomial equations is nothing but an equations involving algebraic expression. Similarly, an equation involving trigonometric functions, we have studied it as trigonometric equations, and in the similar way the equations containing the derivatives are called as differential equation. Thus, we can say the differential equation is nothing but it involves the derivative of the dependent variable with respect to the independent variable in types of a polynomial equation, and it is called as a differential equation. For example, here I have taken x into dy by dx. We know is y is dependent variable and x is independent variable. That is why we take dy by dx as derivative of y with respect to x. So therefore here an equation is involving the derivatives of a function, that is called as a differential equation. And here in the second also 2 into d square y by dx square plus dy by dx whole cube is equal to 0. Second order and first order derivative, dy by dx minus cos x is equal to 0. So this is all an example for differential equation. So like this, as in the case of polynomial equations, you have a degree of a polynomial. Similarly, in terms of the derivatives, so in differential equation, we have to study about the order as well as the degree of the differential equation. What do you mean by order of a differential equation? So whenever the function is given, whenever function y is given, if you derive it once, it is called as first order derivative. If you devise it twice, it is called as second order derivative. We have studied in differential calculus, and we represent dy by dx. So this is called as first order derivative. And when you derive it again, it is d square y by dx square. This is called as second order derivative. And when you derive it again, then it is d cube y by dx cube. This is called as third order derivative. Similarly, you can derive n number of times, and it is represented as d to the power n y dx to the power n. So this is nth derivative. So how to represent the order in a specific equation? So order of a differential is nothing but the order of the highest order derivative occurring in the differential equation. Suppose in the previous example I have x into dy by dx plus y. So here the highest order you have is only first derivative and first derivative. So therefore order of this function is equal to 1. And in the second case, you have dy by dx, the first order as well as the second order. But second order is the highest order of this differential equation. So therefore, here we take order of the function as 2. Similarly, in the third case, we can take order of this equation is 1 because the highest order derivative is dy by dx, which is the first order. That is why we take order as 1. So like this, we are going to find the highest order in the differential equation, and that will be the order of the differential equation. Next, we have one more that is called as the degree of the differential equation. So what is the degree of the differential equation? So degree of the differential equation is defined if it is a polynomial equation of its derivative. It has to be free from all radicals. It should not contain any function with it. So dy by dx or d square by dx square should be like a polynomial equation. Now degree when defined, when it is only defined, how it is defined? in terms of a polynomial equation. So if it is defined, then the degree of the differential equation is the highest power of the highest order derivative. So highest power of the highest order derivative. So take an example, x into dy by dx minus y is equal to 0. So what is the order of this differential equation, or the highest order of this differential equation? So here order is 1. So how many times dy by dx is repeated here? Only once. Hence we say degree of the differential equation is 1. Suppose I say xy d square y by dx square minus dy by dx whole cube plus sin x is equal to 1, some 1. So take any example of this differential equation. We have dy by dx also, we have d square y by dx square also, but which is the highest order? Order is 2, because d square y by dx square is the second order derivative. Hence the order of this differential equation is 2. And what is degree? So highest order is how many times it is repeated, or the power of the highest order. What is the power of this highest order? It is 1. So therefore here degree of the differential equation is 1. I can take an example of dy by dx plus sin y is equal to 1. So what is the order of this differential equation? Order of this differential equation is 1. What is the power of dy by dx? How many times it is repeated? So it is once. So therefore the degree of the differential equation is 1. Similarly, we arrive at some type of polynomial equation. For example, if I take e to the power y dash is equal to 0. What is y dash? Y dash is nothing but dy by dx. So we have studied the different forms of derivatives like y dash, y1, which is nothing but dy by dx. Y double dash or y2 is nothing but d square y by dx square. But here dy by dx, or the derivative, is not in terms of a polynomial equation. It is with the function or with exponential function. So if the derivatives are inside or in terms of powers of any other exponential or logarithmic or any trigonometric function, then we say the degree of the differential equation is not defined. Why? Because to define a degree of a differential equation, it has to be expressed in the polynomial form only. It has to be free from all radical. It should not contain any exponential or logarithmic or any sine cos function along with dy by dx. So dy by dx or d square y by dx square or any sort of order of derivative must be free from any other function. So here let me take an example now. We have a x plus cos dy by dx is equal to 0. So order can be defined because we have dy by dx, which is a first order. Order is defined. So therefore its order is 1. But degree of this function is not defined because dy by dx is along with one more function, that is cos function. So cos dy by dx, so we can't define the degree of the differential equation. So therefore we write it is not defined. So whenever these type of differential equation exist, the degree cannot be defined, and hence we write the degree of the differential equation is not defined. And always note that the order and degree of the equation is always a positive integer. It cannot be 0, it cannot be negative or any fraction. So it is clearly a positive integers, or we can say it's a natural numbers. So here we have find the order and degree if defined for each of the following differential equations. So if it is defined, we are going to write the order and degree of the differential equation. First one, dy by dx minus cos x is equal to 0. Clearly, the derivative is in its polynomial equation form and the order here is 1 because it's a first order derivative. What is the degree of this derivative? Degree is also 1. Next, xy d square y by dx square plus x into dy by dx whole square minus y into dy by dx is equal to 0. So here we have both first order as well as second order derivative. So order is nothing but the highest order derivative. So therefore what is the order of this differential equation? Order is 2. What is the degree of this differential equation? How many times the second order derivative is repeated? Only once. So therefore degree is 1. So highest order and power of the highest order. So power of highest order is 1, which is nothing but the degree of the differential equation. Next, y double dash y square e to the power y dash. What is the highest order? We have both y dash and y double dash. The y dash is nothing but dy by dx. Y double dash is nothing but, here it is d square y by dx square. So here order can be defined. So therefore order of this differential equation is 2. But to define a degree of the differential equation, the derivative must be in a polynomial equation form. It should not be with any other function. But here dy by dx is in the exponential form. So therefore here we say that degree not defined. We write it as nd. So not defined because it is clearly with another function. Next, d square y by dx square whole square plus cos dy by dx. The highest order is 2. So therefore we can say order is equal to 2. But degree is not defined. Why? Because dy by dx is with another function, that is cos function. If it is in this case, if there is no cos, we can write order is also 2, degree is also 2. But derivative is with another function. Hence here it is not in the polynomial form. So therefore we write degree is not defined. Next, d square y by dx square whole cube plus dy by dx whole square plus sin dy by dx plus 1. Again here it is not expressed in terms of a polynomial equation. We have dy by dx along with sin. So therefore here degree is not defined, but order can be written. So therefore what is the highest order here? Highest order is the second order. So therefore order of this differential equation is 2. Next, y double dash 2y dash plus sin y. Clearly it is in terms of a polynomial equation because all the derivatives are separate in terms of terms there. So y double dash means d square y by dx square, y dash means dy by dx. So we have derivatives in the form of polynomial equation. So therefore what is the order of this differential equation? Order is 2, degree is 1. Because y double dash you have only one type. Next, 2x square d square y by dx square minus 3 dy by dx plus y is equal to 0. So clearly we can write order of this differential equation is 2 and degree of the differential equation is 1. Because d square y by dx square is repeated only once. So therefore degree is 1, order is 2. So this is how we are going to write the order and degree of the differential equation. Note that degree is defined only when the derivatives are expressed in terms of polynomial equation. It should not be with any other function, and both order and degree of differential equations are natural numbers. That is, it means a positive integers. Next we come across the general and particular solution of a differential equation. So we know that all polynomial equations has its own solution. Similarly, all differential equation also have its solution. So what is it? So any function which will satisfy the differential equation is called as the solution for the differential equation. And here in differential equation we have two types of solution. So one is general solution and one is particular solution. So what is general solution? For example, whenever the differential equation is given and whenever any function is given, so that we have to find it as a solution of the differential equation. If the solution contains any constants inside it, then it is called as general solution. If the solutions are free from all sorts of constant, then it is called as a particular solution. So let's see here now, a function which satisfies the given differential equation is called as its solution. The solution which contains as many as arbitrary constant. We say it as an arbitrary constant as the order of the differential equation is called as general solution. So as I said, this is a general solution. Next is the solution which is free from arbitrary constant. So there will be purely only the function, not any constants. So then it is called as a particular solution. So look here, the number of arbitrary constant in the general solution of a differential equation of fourth order or. Okay, so we know that, so for n number of degrees, there will be n number of solutions. Similarly, we have n number of constants also. So, like in the same way as in the case of polynomial, if you have the first order derivative, we will have one constant. If you have second order derivative, we will be having two constant. If it is third order, it is 3. Similarly, it is the fourth order, then it contains 4 arbitrary constant. Similarly, if your differential equation or if the general solution whose differential equations are of nth order, then the number of arbitrary constant is equal to n. Next, the number of arbitrary constant in the particular solution of differential equation of third order. As I said, particular solution is free from arbitrary constant. There will be no arbitrary constant in particular solution. Hence, it may be of any order. It may be first order, third order, fourth, fifth or nth order. But always remember, for any particular solution, the number of arbitrary constant is 0. But for general solution, the number of arbitrary constant is equal to the order of the differential equation. But for particular solution, it is always 0. Next, verify that the function e to the power minus 3x is a solution of the differential equation. So here we have a differential equation given and the function is given as y is equal to e to the power minus 3x. Now we need to verify whether this is the or this function is a solution of this differential equation. How to verify? Consider the LHS, show that the answer is equal to 0, then it is a solution for the differential equation. If it is not equal to 0, then it is not the solution for the differential equation. So let me take y is equal to e to the power minus 3x. Remember, if y is equal to e power ax, then dy by dx or the derivative is equal to a into e power ax. Now here in the place of a we have minus 3. So let me find what is dy by dx because the equations contain dy by dx. So this becomes minus 3 e to the power minus 3x. Next again differentiate this because we need d square y by dx square. So already we have minus 3. So derive e power minus 3x again. Then it is again e power minus 3 into e power minus 3x. So which becomes 9 e power minus 3x. So let us take the left hand side of the equation. So LHS is equal to d square y by dx square plus dy by dx minus 6y is equal to 0. So what is d square y by dx square? We got 9 e to the power minus 3x. What is dy by dx? We got 3 e to the power minus 3x. What is this? E power minus 3x. So 9 e power minus 3x minus 3 minus 6 becomes minus 9. So therefore this is 0. Hence LHS is equal to RS. So therefore e power minus 3x is the solution for the given differential equation. So we got that LHS is equal to 0, which is the RHS given. Hence e power 3x is the solution for the differential equation. Next, verify that the function y is equal to a cos x plus b sin x, where a, b belongs to r, which is a real number, is a solution of the differential equation d square y by dx square plus y. So remember here the differential equation is given in the second order and here obviously we have two constant. One is a cos x plus b sin x. So let us find y is equal to a cos x plus b sin x. So let me derive it once. dy by dx. A is constant, derivative of cos is minus sin x plus b, derivative of sin is cos x. Do not confuse with the integration and differentiation. So both are different here. Next, we have here d square y by dx square. Again differentiate it as minus a cos x minus b sin x. So consider LHS here. LHS is equal to d square y by dx square plus y. What is d square y by dx square? Minus a cos x minus b sin x. What is y? It is a cos x plus b sin x. So clearly you can see minus a cos x plus a cos x minus b sin x plus b sin x is equal to 0, which is the RHS. So therefore, hence we can say y is equal to a cos x plus b sin x is the solution for the differential equation given. Next, verify that the given functions, explicit or implicit, is a solution of the corresponding differential equation. So here some of the differential equations are given and some functions are given. It may be an explicit function or implicit function, but we have to verify whether it satisfies the differential equation. Now here we have y is equal to e power x plus 1. The differential equation given is y double dash minus y dash. Y dash means differentiate it once. So what is derivative of e power x? E power x. What is derivative of 1? It is 0. Next we take y double dash. What is derivative of e power x? It is e power x. And now let us consider this y double dash minus y dash. What is y double dash? E power x. What is y dash? E power x. Both get cancelled. So this is equal to 0, which is the RHS. And here we have the left hand side of differential equation. Hence we got LHS is equal to RHS. Therefore, conclude y is equal to e power x plus 1 is the solution for the given differential equation. Next, xy is equal to log y plus c. So we have an implicit function here. So the given differential equation is in this form. Y dash is equal to y square divided by 1 minus xy. Xy cannot be equal to 1 because it becomes 0. Now here, let us derive this function. We need y dash. So if first order derivative is enough for this, so x into derivative of y can be written as y dash plus y into derivative of x can be written as 1. Apply the product rule. What is derivative of log y? It is 1 by y dy by dx, which is nothing but y dash. What is derivative of c? It is 0. So now here we have, take y dash as a common factor, shift here. So then it is x minus 1 by y dash is common, plus y is equal to 0 here. So next we have xy minus 1 divided by y dash is equal to minus y. Shift y there. So then you have xy minus 1 y dash is equal to minus y square. So then y dash is equal to minus y square divided by xy minus 1. So take minus outside here. So therefore if you take minus outside in the denominator, then it becomes y dash is equal to y square divided by 1 minus xy. So if you take minus outside, it is minus into minus plus, then we get y dash as y square divided by 1 minus xy. Hence proved. So therefore this is the solution for the differential equation. Next, y is equal to root of a square minus x square. X belongs to minus a comma a. We have to show that x plus y into dy by dx is equal to 0, where y is not equal to 0. So now let us derive this. We need dy by dx. We know that if y is equal to root x, then derivative of this function becomes 1 by 2 root x. So therefore what we can do here, so dy by dx, so if this is root x, then that is 1 by 2 root of a square minus x square. But in the place of x, we have a square minus x square. Derive it again. Apply the chain rule of differentiation. So derive a square minus x square. A square is constant, so it is 0. Next we have minus. Derivative of x square is 2x. So here 2 get cancels. So next we have dy by dx is equal to minus x divided by root a square minus x square. But what is root a square minus x square? It is nothing but y. So replace it, minus x divided by y. Shift y here, then it becomes y into dy by dx is equal to minus x. Shift minus x to the left hand side, then it becomes x plus y into dy by dx is equal to 0. Hence, we have proved. So, we are arrived at the equation x plus y into dy by dx is equal to 0. Hence, we can say this is the solution for the given differential equation. So, thus in today's session, we have learned order, degree, and we have learnt about what is general solution, particle solution, and we have verified whether the given function is the solution for the differential equation or not. So, finding order and degree of the differential equation, you can say it's a compulsory equation. So, degree and order. If you write, you will get 2 marks in your examination. There will be one compulsory question to find the order and degree of the differential equation. And these are all very simple problems which may ask it for 1 or 2 marks in your examinations. So, we'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.